Welcome to Agal classroom. Today in this video we are going to see about thermodynamics. Thermodynamics is a branch of physics that deals with heat and temperature and their relation to energy, work, radiation and properties of matter. Thermodynamic process. The thermodynamic process is a passage of thermodynamic system from initial to final state of thermodynamic equilibrium, that is known as thermodynamic process. Thermal equilibrium. When two systems are said to be in thermal equilibrium if there is no net flow of heat between them when they are brought into thermal contact, that is known as thermal equilibrium. In physics, a microstate is defined as an arrangement of each molecule of molecules in the system at a single instant. A macrostate is defined as macroscopic properties of systems such as temperature, pressure, volume, etc. If the macroscopic variables such as pressure, temperature, volume and mass etc. which characterize a system do not change with time, the system is said to be in thermal equilibrium. Thermodynamics is concerned with macroscopic behavior rather than the microscopic behavior of the system. The law of thermodynamics is define the fundamental physical quantities like energy, temperature, entropy that characterize the thermodynamic system at thermal equilibrium. The laws represent how these quantities behave under various circumstances. There are four laws of thermodynamics out there. They are Zeroth Law of Thermodynamics, First Law of Thermodynamics, Second Law of Thermodynamics and Third Law of Thermodynamics. What is zeroth law of thermodynamics? When a body A is in thermal equilibrium to another body B and also separately in thermal equilibrium with the body C, then body B and C will be in thermal equilibrium with each other. This is known as zeroth law of thermodynamics. This law leads to a concept of temperature. For example, let us consider thermostat in our room which reads 68 Fahrenheit. This means that thermostat is in thermal equilibrium with your room. Because this is a zeroth law of thermodynamics, we can assume that both the room and other objects in the room also reach 68 degree Fahrenheit. Let us see another example. If you take a glass of ice water and a glass of hot water, place them in a kitchen, after few hours, they evenly reaches the thermal equilibrium with the room. With all the three reaches the same temperature. That is known as, this is also an application of zeroth law of thermodynamics. Now let's see the first law of thermodynamics. First law of thermodynamics is otherwise known as law of conservation of energy. Law of conservation of energy can be defined as a energy can be neither be created nor be destroyed. It can be transferred from one form to another form. The change in internal energy of a system is equal to heat added to the system minus work done by the system. Del U is equal to Q minus W. Del U is equal to, it's nothing but a change in internal energy. Q is heat added to the system where W is work done by the system. Let us see some of the applications. The light bulb transfer electrical energy into light energy. This is an application for first law of thermodynamics. Now let's see the second example. Plant convert the energy of sunlight into chemical energy stored in organic molecules. This is also a application for first law of thermodynamics. Let's see some of the questions related to the zeroth law and first law of thermodynamics. First question. What quantities appears in the first law of thermodynamics? Option A. Force, mass, acceleration. Option B. Inertia, torque, angular momentum. Option C. Work, heat, thermal energy. Option D. work, heat, entropy, and option E, enthalpy, entropy, and heat. Here, work, the first law depends upon work, heat, and thermal energy. Therefore, the answer is C. Now, let's see the second problem. The internal energy change in the system that has absorbed 2 kilocalories of heat and done 500 joule of work. Let us consider 1 calories as 4.2 joule. The options are 6400 joule, 5400 joule, 7900 joule, and 8900 joule. Let's see the explanation. According to the first law of thermodynamics, Q is equal to del U plus W. In another way, we can write del U is equal to Q minus W. Here Q is nothing but 2 kilocalories. So 2 into kilo in the sense 1000. 1 calorie is equal to 4.2 joule. Therefore 2 into 1000 into 4.2, which is equal to 8400, minus work done is given in a question as 500 joule. So 8400 minus 500, the answer is 7900 joule. So option C is the correct. In a given process of an ideal gas, del W is equal to 0 and del Q is less than 0. Then for a gas, option A, the temperature will decreases. Option B, the volume will increase. Option C, the pressure will remain constant. Option D, the temperature will increases. Let's see the explanation. First law of thermodynamics. So del Q is equal to del U plus del W. Here del Q is equal to del U when del W is equal to 0. When del W is equal to 0, automatically del Q is equal to del U. When del Q is less than 0, then del U is also less than 0. So automatically the temperature will decrease. Option A is the correct answer. Next question. When heat energy of 1500 joule is supplied to a gas at constant pressure 2.1 into 10 power 5 Newton per meter square, there was an increase in its volume to 2.5 into 10 power minus 3 meter cube. The increase in internal energy of a gas in a joule is option A 4500 joule, option B 525 joule, option C 975 joule, option D 2025 joule. Let's see the explanation. Here work done is equal to pressure into volume. So first law of thermodynamics, del Q is equal to del U plus del W. So work done is pressure into volume. Here the pressure they have given and volume also they have given. If you multiply pressure and volume, you will get work done. Here pressure given us 2.1 into 10 power 5 Newton per meter square and volume given us 2.5 into 10 power minus 3. Therefore work done is 525 joule. So del Q is equal to del U plus del W. Del Q is 1500 minus 525. Then del U is equal to 975 joule. So the option is C is the correct answer. Let's see the other problems in the next classes. If you like it, comment, share, subscribe the Agal class. Thanks for watching.